Hello, my name is LBB, and my index number is 220362G. And welcome to the second assignment of Medibox. And this is my workflow code for the second assignment. And initially, I have included all the libraries needed for this second assignment. And then these are the pin definitions. And these are the Wi-Fi credentials I have used, the public Wi-Fi given by the workflow platform. And this is the server details. I have used the broker.emqxio.io server, and this is the port number and the client ID. And here I have used several topics that will be used actually in the Node-RED dashboard and actually nodes of the Node-RED. And these are the global variables. And the parameters I have used in my code, such as the sampling interval, which is 5 seconds in milliseconds, or 5 seconds, which is like the default parameters given for the second assignment. And the sending interval is 2 minutes. And the offset, 30 degrees. The control factor, gamma, in 0.75. And then the ideal temperature, 30 degrees. And there are several other variables in this code. And these are the functions I have used in my code, such as setup Wi-Fi, the reconnect MQTT, the callback function to send data and also receive data from Node-RED, and then read density, intensity, read temperature, then calculate an server angle, and then update the server position based on the received angle, and then calculate average light intensity. And this is the setup code. I have set up several functions here as well, such as the DHT sensor and the servo and the Wi-Fi, and also the loop code. I have repeatedly running several functions as well, such as to calculate the time taken to update the light intensity of the Medibox, as well as to store the light intensity values and to display it in the serial monitor for debugging purposes. And moving on, this is my Wi-Fi setup function to set up Wi-Fi and to connect to the server. And this is the broker connection where I will connect to the MQTT connection and send data through the server to the Node-RED. And this is the callback function to receive in data from the dashboard. So when I change the parameters in the dashboard, I can update the code and show the results in the serial monitor as well. And in Node-RED, I have used several nodes to control light intensity. I have used the gauge as well to show it, and also the temperature to show the temperature in the gauge, and also to plot the graph. And sampling interval can be set by the user as well in the Node-RED dashboard, such as same as the sending time interval as well, and the offset angle, control factor, and the ideal temperature as well, like to store the medicine in any box. My dashboard, as you can see, I have included the gauges to show the temperature and light intensity, both of them, and the graphs to plot light intensity and the temperature. And the user can change the sampling interval and the sending interval, as well as the user can set the minimum angle offset, control factor, and the ideal temperature as well. Now let me show you the functionality of this code. Now it's connected into the Workplace Wi-Fi. And in the serial monitor, I am printing the sampling interval update from the dashboard. So if I change these parameters, it will automatically reset these values accordingly. So if I change the sampling interval, now it's at 26 seconds. If I interval it to change it to 33, it will show that it is 33 now. This is in milliseconds. And if I change the sending interval, which is currently in 5 minutes, I change the offset, which is now in 39. If I increase to 50, it will show it has been changed to 50. And the control factor, which is now 0.31, if I change it to 0.37, it will show that it has been changed to 0.37. And then if I change the ideal temperature, which is now 23 degrees Celsius, if I change it to 25, it will show it's changed to 25. And also the temperature currently it's 17.9 degrees Celsius, and it's been displayed in this temperature gauge. And if we go into the LDR, it's at zero point 0.2, so it has displayed zero point 0.2 here as well after being normalizing. So if I change the temperature to 60.3 degrees after few seconds, it will change the temperature in the dashboard as well. So after 2-minute time intervals, the graphs and also the gauge will be updated as the default time to show the values. And whenever I change the temperature, the servo angle will be changed. As you can see, the servo angle has been changed, as well as the temperature is changed in here as well. Thank you, and that's my demonstration for assignment 2.